Okay, welcome everybody to our 1.7 concept video where we're going to be learning about the chain rule. And in this section, we're continuing with the same idea of how can we find derivative rules that's going to make this process of taking a derivative much simpler. Last time we learned about the product rule and the quotient rule for if you have functions that are being multiplied or divided together. And this time, we're going to be learning about what do you do if you have a composition of functions, or a function inside of another function, right? In this case, h of x would be my inside function, and g of x would be my outside function. So the question is, how do you take a derivative of something like this? Well, the chain rule is our formula for that. Turns out all you need to do is take the derivative of the outside function, keeping the inside function the same, and then you multiply it by the derivative of the inside function. And that's the chain rule. Well, right now this may not mean much and might seem a little confusing, so let's think about where this actually comes from. So let's consider a certain situation where we've got a function y, and we want to find the derivative of y in terms of x. Remember, this is my notation, this is my alternate notation for derivatives. It's called Leibniz notation. But let's assume that y is a composition function, meaning that it's a function of another function which we'll call u, where u is a function of x. Right? We could put these two together if we wanted to, just to kind of see the same thing that we had earlier. But we're going to let u represent that inside function. So bear with me here as I kind of introduce a new variable. Well, using just a little bit of algebraic manipulation, I can rewrite dy over dx as dy over du times du over dx. Hopefully you can see how the algebra checks out here, right? These two du's cancel, leaving me with dy over dx, which is what I started with. So the algebra checks out. These two sides are equivalent, but what does this tell me? This tells me that the derivative of y in terms of x is equivalent to the derivative of y in terms of the inside function. Another way I could write that, or another way I could think about it, is g prime of u multiplied by the derivative of my inside function in terms of x. Well, how can I think about that? I can think about that as just h prime of x. And so I end up with what I have in the chain rule, where if I want my derivative, I take the derivative of the outside function with u plugged in, where u is that inside function, multiplied by the derivative of my inside function. So that's where the chain rule comes from. It just comes from this simple algebraic manipulation of the Leibniz notation. Kind of the biggest obstacle with chain rule is just recognizing when to use it. So to use chain rule, we need to have a composition of functions. So we're looking for any time where we have a function inside of a function. Well, the easiest way we'll see this is if we have parentheses. Right? If I see something like that, that's obviously a composition of functions because everything inside of the parentheses is my inside function. Everything inside of the parentheses represents your inside function. And then my outside function, what would g be? G of u is just raising that function to the fourth. And I'm raising my inside function to the fourth power. And so that gives me a very simple derivative for my outside function. I just get 4u cubed. And so if I wanted to put this all together, my derivative would be 4 with my inside function plugged in, 3x squared plus 5, raised to the third power, multiplied by the derivative of that inside function, which is just 6x. And so there's my derivative. Not too bad. Where else might you see composition of functions? Well, as we start talking about different types of functions, as we get into exponential functions and log functions, we're going to learn about some more cases. But as for now, the only other circumstances where you're going to see this is if you see something like this. This counts as a composition of function because what's my inside function? Everything inside of the square root. So roots is another common place where we see a composition of functions. If you're rooting a function, then you have a composition of functions where that's your inside function. Everything inside the root is your inside function, and then your outside function is just that root function, which of course counts as a power function, right? This is u to the 1/2. And so I can use the chain rule to help me actually find the derivative of this root function. Okay, that's really all there is to chain rule. Go ahead and try this out on your own on the homework. And then if you have questions, go ahead and watch my example video for 1.7, where I'll go through a couple of the questions from the 1.7 homework. Good luck, guys.